Hello, and welcome to Percent Yield, the 7th video in the Scale Factor Stoichiometry series. In this video, to be successful, you need to already know what it means to mass balance equation. You should know how to scale equations to a given situation. You should be able to interpret scale equations. What does this mean? And you need to be able to determine a limiting reactant. So we will be having limiting reactants in these. And you should be able to do them using the scale factor method. If you are watching this video, learning how to do percent yields, but have not learned the scale factor method, then you should go watch the previous videos in this series because it is different from the standard dimensional analysis method. So with that said, I will assume that you know how to use the scale factor method to do all those things and teach you in this video how to define actual yield, theoretical yield, percent yield, and then how you're going to calculate percent yields from given information. Let's have some definitions. The actual yield, which is sometimes just called the yield, is the amount of something made by a reaction. And this term is used in farming and cooking as well as chemistry. Farmers refer to crop yields. This acre yielded 1 ton of potatoes. And some recipes will refer to yield as how many cookies or how many pancakes you could expect to make. So it gives you the recipe and then says yields 24 cookies. So yield, that is how much is made. That's what you actually get. Now, the theoretical yield is the amount you expect to produce, and you'll usually get this from rescaling a mass equation. But you'll do a calculation, you'll say, all right, the theoretical yield is what you expected to get from a reaction. So the cooking recipe, the 24 cookies is theoretical. That's what we think you'll get if you make it. The percent yield is the ratio of the actual yield to the theoretical yield expressed as a percent. And instead of saying more words about that, we're going to look at an example. So there's the equation for you. And percent yield is just like your percent on a test. So if you think about taking a test, the percent is what you got, that's your actual, divided by the points possible, that's the theoretical, times 100%. This assumes no extra credit on the test, but that is your percent, what you got, divided by the points possible, and then multiplied by 100%. So if you got 32 points on a 36-point test, what was your percent? Well, just 32 over 36, right? Your actual over your theoretical, multiplied by 100%, and there you have it, your 88.9%. B+. Time to see what this looks like in the world of chemistry. So the easiest percent yield problems you could possibly be asked will just simply straight up tell you this was your actual, this was your theoretical. So for example, you're told a reaction that was supposed to make 2.50 grams of silver only made 2.15 grams of silver. What was the percent yield? Well, there's the actual. You were told what it made over the theoretical, what it was supposed to make. And we're just going to divide the actual by the theoretical, and it was an 86% yield. Or here's another one. The actual yield of water in a reaction was 32 grams. The theoretical yield was 50. What was the percent yield? Well, this was nice. They actually threw the words actual and theoretical at you, so you didn't even have to figure anything out. So you take the actual, put it over theoretical, and multiply by 100 to get the percent, and that was a 64% yield. Something that's not mentioned a lot with percents, but I'm going to go ahead and bring it up, is that they are dimensionless, because if you look at the units on top, grams of silver over grams of silver, grams of water over grams of water, they cancel. So percents are dimensionless. So let's go ahead and look at a actual problem that you might see that is a little bit more difficult. 1.50 grams of magnesium is burned in air and produces 2.35 grams of magnesium oxide ash. What was the percent yield? In order to solve this problem, we need to know our actual yield and our theoretical yield. Let's look at the equation. So we can see that magnesium is a reactant, oxygen is a reactant, and we're making magnesium oxide. So that tells us that this 2.35 grams number, that is our actual yield. We are just being told that this reaction made 2.35 grams. And now we need to figure out, well, how much did we expect to make? So it's time to apply the scale factor method. This is the standard mass balanced equation. And if you run the standard equation, you expect to make 80.6 grams of magnesium oxide. But we didn't use 48.6 grams of magnesium. We used 1.5. That's our situation value. So we're going to apply a scale factor here. Grams of magnesium will cancel. Scale factor is 0.03086. Applying the scale factor to the entire equation, tells us that we expected to make 2.49 grams of magnesium oxide. So this is the theoretical yield. Once you have rescaled your mass balance equation, the theoretical yield is what shows up on the product side. So our theoretical yield of magnesium oxide was 2.49. Now the percent yield equation is fairly straightforward. It's simply what we got over what we expected to get multiplied by 100, and 94.5%. Not bad. That's pretty close, right? If you got 94.5% on a test, you probably feel pretty good about that test. So what makes theoretical yield problems, percent yield problems, a little bit more difficult is you'll be handed lots of numbers, and figuring out what you need to do with each of those numbers can be a little disorienting at first, especially if there is a limiting reactant, as we're about to see here. So 0.65 grams of silver are collected when 0.5 grams of copper are placed in a solution with 2.5 grams of silver nitrate. And we're being asked the percent yield. So lots of numbers here. Let's figure out what we're going to do with them. 0.65 grams of silver are collected. That is a product. Okay, so that is a yield. We are getting it. That means that this number is going to show up in our percent yield equation. This is our actual yield. These numbers here are amounts that were used, and it looks like we're going to need those to rescale the equation. Unlike the previous equation, where we were just given one reactant, and we just assumed we had all the oxygen we needed, this is a limiting reactant problem, and we're going to have to figure out how many grams of silver we expect to make based off limiting reactants. So we need a scale factor for silver nitrate. We can see our silver nitrate scale factor is 0.00736. And then we're going to get a scale factor for copper. Our scale factor for copper is 0.007874. Grams of copper will cancel. And so we can see that we are limited by the silver nitrate. We will apply the silver nitrate limiting, its limiting reactant. We'll apply its scale factor to the equation. Well, there's actually no need to apply it to the entire equation, because all we really care about is the percent yield of silver. So we find that when we apply it to the amount of silver that we expected to make 1.59 grams of silver, and so the percent yield is the 0.65 grams that we actually got over the 1.59 grams that we thought we would get, and we only got 48.9%. That's pretty bad. We got less than half the silver. Not quite sure where it went. Why did we do such a bad job of collecting the silver? But, it could be that the ninja chemist has made an appearance and has stolen a significant chunk of our silver. This could be problematic for us for our yields going forward. So perhaps the ninja chemist is hot on the tail of that chemistry teacher who sold silver on the black market, and now he's going to have a much harder time doing this because she is going to show up and eat into his yields. All right, well, it's practice time. The percent yield, what is the percent yield if burning 5 grams of hydrogen produces 44 grams of water? This one is a straightforward problem that does not have a limiting reactant, and there you have your mole balanced equation for you. And then the next one will have a limiting reactant. Okay, 2.5 grams of silver are produced when 2.5 grams of copper react with 25 grams of silver nitrate. So you'll need to look at these questions and figure out what is the theoretical yield. You'll need to figure out what's the actual yield, and that's going to involve scaling the equations. The actual yield is usually handed to you in the problems, and I've done that here as well. So go ahead and pause the video now, please, and figure out what the percent yields were, and I will wait patiently for you, and we will see if you're able to get through these problems successfully. Okay, welcome back. I hope you have had success at solving these problems. Let's see what happens when we apply the scale factor approach to these problems. So for the water, there's our mass balanced equation. There's our scale factor that's based off hydrogen, and our scale factor is 1.25 grams of hydrogen. You cancel, and we find that we expected to make 45 grams of water. That is our theoretical yield. And then our percent yield was 44 over 45, and that gives us a very good yield, 97.8%. Very good. We got almost all the water that we expected to make there. Grams of water do cancel, as always. There is our copper reacting with silver reaction. And then we need to get two scale factors, the silver nitrate scale factor, and then that's 0.0736. The copper scale factor, 0.0394. Okay, and so it turns out that the copper has limited us this time. When we apply the copper scale factor to the silver that was in the standard amount, we find that we expected to make 8.5 grams. When we look at what we actually got, ooh, man, this is worse than before, and so I am just worried that we might be, yes, okay. I am worried that our future silver yields are going to get lower and lower as the Ninja Chemist continues to hack at our experiments here. So hopefully we'll be able to solve that in future chemistry problems going forward, but I hope you're able to get those answers, and I look forward to seeing you in our next video.